Hello everyone and welcome to our channel MooTechie. It's a pleasure to have you here. Today we're diving deep into the fascinating processes of milling and grinding. Now, let's begin our journey with the milling machine. Milling may be defined as a machining operation for removing excess material from a workpiece with a multi-tooth rotating cutter. Flat or curved surfaces of many shapes can be machined by milling with good finish and accuracy. A milling machine may also be used for drilling, slotting, making a circular profile, gear cutting or helical milling with suitable attachments. Generally, the workpiece is fed past the rotating cutter, but sometimes feed may also be given to the cutter. The teeth of the cutter act as individual cutting edges, each producing a small chip of its own. Moving forward, let's explore the different types of milling machines. Knee and column type milling machines are the general purpose machines most widely used in industry. They are capable of producing flat or formed surfaces and may also be used for gear or spine cutting, helical milling, drilling, boring and slotting when provided with suitable attachments. These machines are available with vertical or horizontal spindles and may be of plain or universal type. Now let's look at a detailed diagram of a typical milling machine. We'll go through each part to build a clear picture in your mind. We start at the top with the overarm. Connected to that is the arbor support, which has a yoke. Below that we see the cutter mounted on the arbor. On the table we have the machine vise, which is holding the workpiece. The work is sitting on the table, which is on the saddle. Below the saddle is the knee. Under the knee is a screw jack, all resting on the base. On the main column we have the spindle nose, the column itself, the guideways, and the vertical traverse handle. And finally, supporting everything is the base. Next, we explore a specific type, the plain horizontal knee and column type milling machine. A plain horizontal milling machine has a rigidly supported horizontal arbor on which the cutters are mounted. The spindle of the machine is hollow with an internal taper at the end to accurately locate the arbor or the shank of a milling cutter. Arbors are held in place by a long bolt called drawbar. This screws into the tapered end and is fastened at the back of the machine. The knee of the machine is mounted on the column and can be adjusted or fed lengthwise on top of the saddle in the third coordinate direction. Feed may be given by hand or power. The overarm extending from the top of the column carries a support for the outer end of the arbor. Braces are available to tie the arbor support and overarm to the knee for added support. Workpieces, various attachments and milling fixtures are fixed on the table, making use of the T-slots provided on the table for this purpose. Now let's meet the tools that do the actual cutting, the types of cutters. This classification of cutters is based on the general shape of the cutters, or the type of work they will do. We have plain milling cutters, side and face cutters, sitting saws, angle milling cutters, form milling cutters, end mills, and T-slot cutters. Let's understand each of these cutters in more detail. 1. Side and face cutters. These cutters are similar to plain cutters except that they have teeth on one or both sides as well as on their periphery. They may have straight helical or staggered teeth. 2. Sitting saws. These are thin arbor mounting cutters with a thickness of 5 mm or less. They resemble plain milling cutters, with cutting edges only on the outer surface. They are used for producing narrow slots or for parting off operations. 3. Angle milling cutters. The teeth on these cutters are cut on conical surfaces. Both single and double conical surface cutters are available. Angle cutters are used for machining dovetails, ratchet wheels, flutes on reamers, etc. 4. Form milling cutters. Cutters of this type include concave and convex cutters, gear cutters, fluting cutters and many other cutters with special contours. These cutters produce an inverse replica of the shapes of their cutting edges on the workpiece. 5. End mills. These are shank mounting cutters with teeth at the end as well as on the periphery. They have either straight or helical flutes. They are used for cutting slots, producing recesses, squaring ends or surfacing. 6. T-slot cutters. Cutters of this type are used for cutting T-slots. They resemble small plain milling cutters with straight or tapered shanks for holding in the spindle. As we continue, let's shift our focus to another crucial machining process, grinding. Grinding is a metal cutting operation performed by means of a rotating abrasive wheel that acts as a tool. This is generally used to finish workpieces which must show a high surface quality, accuracy of shape and dimensions. Mostly, grinding is the finishing operation because it removes comparatively little metal, about 0.25 to 0.50 mm in most operations, and the accuracy in the dimensions is in the order of 0.000025 mm. That is an incredible level of precision. Now let's visualize a common grinder. We see an image of a bench grinder. It has a guard for safety, a work rest to support the material, and of course the grinding wheel itself. So how is grinding classified? Let's find out. Grinding may be of two types. 1. Rough or non-precision grinding, where the work is held in operator's hand. The work is pressed hard against the wheel or vice versa. The accuracy and surface finish obtained are of secondary importance and considerable amount of metal is removed. 2. Precision grinding, which is concerned with producing good surface finish and high degree of accuracy. The wheel or work or both are guided in precise path. Following this, let's look at the machines that perform these tasks. Grinding machines are of rough type or precision type. Rough grinder may be floor stand and bench grinder, portable and flexible shaft grinder, swing frame grinder, or abrasive belt grinder type. Precision grinders may be cylindrical grinder, internal grinder, surface grinder, tool and cutter grinder, or special grinder type. Let's describe a typical floor stand grinder from the image. We can see a guard, an eye shield for protection, the workpiece being applied to the wheel, a work rest, a water pot for cooling, and the entire assembly mounted on a sturdy pedestal. Now, let's understand the basic construction of these machines. The simplest type of grinder is the floor stand grinder with a horizontal spindle with wheels usually at both ends and is mounted on a base or pedestal. There is a provision for driving the wheel spindle by belt from motor at the rear at floor level. Frequently, the wheels are mounted directly on the motor shaft extensions where the motor is on the stand. The small size machine mounted on a bench is called bench grinder. All the grinding machines operate on the same principle, but the different work holding and wheel driving mechanisms and attachments are provided to achieve desired grinding. The heart of the grinding process is, without a doubt, the grinding wheel. Grinding wheel is a multi-tooth cutter made up of many hard particles which do the cutting. Abrasive grains are mixed with suitable bond which acts as a matrix or holder when the wheel is in use. The abrasive wheel is usually mounted on some form of machine adapted to a particular type of work. It must be hard and tough, and the wheel surface must be capable of gradually breaking down to expose new sharp cutting edges to the material being ground. The material components of a grinding wheel are the abrasive grain and the bond. However, there are other physical characteristics such as grain size, structure and wheel shape must be considered in grinding wheel manufacturing and selection. So what are these grinding wheels made of? Let's talk about abrasives. 1. Natural abrasives include sandstones, silicon quartz, emery corundum and diamond. 2. Artificial or manufactured abrasives include aluminium oxide, known as aluminium and aloxide, and silicon carbide, known as carborundum and crystolon. Abrasive grains are bonded together in the form of grinding wheel generally by bonds like vitrified resinoid rubber, shellac, silicate and oxychloride. Vitrified, resinoid and rubber bonds are the most common. Grinding wheels are made in different shapes and sizes to adopt them for use in different types of grinding machines and on different classes of work. The shapes of the wheels may be straight, cylindrical, cup, dish, segmented, etc. Finally, our last slide simply and effectively shows us the variety available, titled Shapes and Types of Grinding Wheels. This visually reinforces that grinding wheels come in many forms, each designed for a specific task, from simple straight wheels to more complex cup and dish shapes. And that brings us to the end of our detailed look at milling and grinding machines. We've covered everything from the massive components of a milling machine to the tiny, sharp abrasive grains on a grinding wheel. Thank you for your focus and curiosity throughout this lesson. Keep exploring, keep learning, and remember, mastery of these fundamental tools is the foundation of great engineering. Thank you. See you in the next class.